Hello and welcome to another tutorial. So we are going to be continuing with the building up of our character controller. So last time we got the character controller being able to move around, we were able to also look around the environment, and we also got slope limits up and running. And so this was all working using a rigid body based character controller and the new input system. So what we're going to be focusing on this time is starting to get more stuff in regards to vertical movement. So getting falling, feeling good, getting the ability to jump in. We want to also be able to have support for double jumping in. So I want to get a few things like that up and running with this. So let's kick off first with, let's sort of see how falling currently feels. It's not going to feel good at the moment. And that's okay. We understand why. It's because we're directly overriding the velocity all the time. So if I get up here and I run off the edge, then I stay still fairly high up in the air for an extended period. Now the character's going to know that they're not grounded, but it's not really a good experience. So I'm going to get rid of the debug log that's in there. And so now we want to start getting the falling happening. So the falling is going to be able to kick in here. So, because we're updating the movement vector. So are we on the ground? Otherwise, we are in the air. So there are different ways that we could be handling this. Velocity versus force will give slightly different feels, and the feel is very much what this is down to. So what I'm going to do is falling, we'll do public float, and what we will do is I will actually go for velocity based. I feel like velocity based is going to work the best. So for velocity, we will probably need to experiment with this a little bit because we want it to feel it's that right level of sort of quickness. So we'll go for 1 to start with, and we might need to increase that if need be. So in this case, the movement vector, because we're not grounded, that's actually just going to be vector3.down multiplied by our fall velocity. So let's see how that feels. We want something that, as I said, that we land reasonably quickly. That's sort of the feel that we're going for with this. So we're running, we'll run up here because we don't have jump support yet. So it's just going to be a case of running off the edge of this. So that definitely too slow. So we want to really ramp that up a little bit. I think probably I feel like 5. I think it actually needs to be something that is a little bit sort of a decent amount of speed. Even then with that, like it gets there, it's a little bit slow, so it doesn't really feel great yet. The fall velocity, we could increase that to 10. The other thing might be hitting there is our grounded check buffer. So we could probably lower that so we're not checking as large a range. Because remember, that's going to control it thinking whether we're sort of on the ground. So we don't want that to be too large. So dropping that should mean that it's a bit of a better sort of feel there. You kind of want the right balance where it's not so much that it thinks you're grounded when you're a decent amount off it, but not so little that it's constantly bouncing between you thinking you're grounded and not. So that's better. We do still get that sort of slowdown that happens at the end. So what I'm going to do is I'm going to try and actually capture that in the debugger and see what the go is with that. So it's still doing that slow falling at the moment. So I particularly want to see what I'm getting back as the result from the grounded check, because that's something where if we are currently grounded, it could very easily, not grounded, could very easily, yeah. So it thinks we're grounded. If we take a look at the hit result, and what that likely is that's probably down to the radius, potentially. So, because that distance, if we look at, so we'll keep an eye on, so our linked rigid body position, it's minus 3.93. What we'll do is we'll let this run till we're fully on the ground. Then we'll put another breakpoint in. So we're at -4 there. So it's definitely hitting a little too soon. And what that very easily could be is, so the sphere cast, we have this radius here that it's using to check. So ground check radius. And what I am assuming is that what the sphere cast is doing is it does actually move that sphere sort of fully down. So what we probably need to do is from this subtract config.radius. We'll see, but I have a feeling it's, and I'm going to log out, is grounded. Just so we've got that there. I have a feeling that it's picking up a little bit too early, that because that sphere is moving down, we're making contact, that sphere radius above the ground. So it's thinking that we are grounded way too soon. So we'll run over, and it was. So that immediately feels better. I reckon it's still not quite the speed that I would want it to be. I actually feel like that full speed still needs to be a bit faster. So let's run off. That's probably too fast. So that's good. We've kind of got our threshold. And this thing, character controllers, the difference between a good and a bad character controller is really down to feel. It's very, very much down to feel. That's pretty good. I might actually drop it back to like 12.5. Now, the other thing that we might want to support is the idea of having a little bit of in-air control, so that when you're moving, it can continue moving a bit. So what I'm going to have, air control, public pool, can air control is true, and public float, air control, and we'll give that a max speed. So max speed, because we don't want the same level of movement control when we're in the air as we do when we are on the ground. So we want this to be much, much lower. Might make it something like 2.5. Might be a little too low, but I think something like 2.5. Because then with this, well, we can go to our max speed thing here. And with the max speed, I'm going to make this a little bit more complicated. So we'll chuck in a get. And the main reason I'm doing this is just so it's actually easy enough to read. It's very easy for this to become very difficult to read. So F is grounded. Then we do this. Otherwise, we check can air control. If we can air control, then we use the air control max speed. Otherwise, 0. What that will automatically do then is our movement vector here is going to get modified and scaled based upon that value. So what we can do then with this is movement vector plus equals, because we actually, if we don't have air control enabled, movement vector will be getting multiplied by 0, so its value will be 0, the result here will be the same. Fid is already has sort of existing stuff in there, and we do have air control enabled. then it's going to come through scaled based upon that air control speed. So that's good. That should give us the ability to have a little bit of control. We don't want a huge amount of control. We want a little bit of control. So I can run off the side. That feels better. The other thing I can do is, because we've got a case here where we have a massive drop in velocity that we're setting, and it's an instantaneous velocity change, which is not necessarily what we want. So we can actually set up, so our movement, we have a blend rate. It's public float, and we want to have a blend rate. So essentially how rapidly it's going to move to a new velocity. It's kind of effectively going to be an acceleration. The units will probably not work out exactly right for it being an acceleration, but it's in that sort of a similar wheelhouse there for it. It's not exactly an acceleration, but it's going to be largely sort of functioning as an acceleration. So we'll be able to do that. So what we can do is we've got our setup, and we can essentially lerp towards it, or we could do a move towards. So we have our movement vector, that's our input data. And so it comes down to how rapidly we want it to achieve that velocity. So I'm going to do a vector 3 move towards, and we will move from our current one. So linked rb dot velocity movement vector, and we will go. I'm going to call it an acceleration. It's not entirely that. It's roughly functioning as that. So this should just preserve a little bit of any existing velocity we had. The idea being that then if we run off the edge of something, that we go a little bit further than if we just walked off the edge of it. So I'm going to test that by, I will step off the side, so I landed about sort of there. If I then move much quicker, so I'm going to run. So it did end up a little bit, I can't actually see the one, but it did end up a little bit further by the looks of it. We'll test that again, just to get a sense of where it's landing. So yeah, it is a little bit further. I'm 3 squares, fully 3 squares to the side when running, whereas with the other one, if I just walk off, then I'm about 3.5. So it is making a little bit of a difference there with it. We could adjust stuff like that air control speed, things like if that will give a bit of a better result there too as well. But so we've got the ability to fall. That's good. So falling's feeling all right. Now we want jumping, and we want jumping to feel good. So I'm going to have header jumping. It's public bool. Can jump. Should be true. We also are going to have a can double jump, which will set to true. So when we jump, jumping is a tricky one to get it feeling really good. So we're working largely with velocities, so it means we kind of need to apply a bit of velocity for a time. So public float jump, and we can apply it for a time. But the other thing with that is, depending upon how long it's been, we could get a lot of variation with that. We'll see how it goes, because we want to be able to reliably jump a consistent height is the big thing. So we'll see how we go with just setting that we have like a jump time. Likely what we'll find is that we actually want to have a setup where we set a jump height and we have a velocity that we apply until we hit that height. So we're going to have our jump velocity. Now, from seeing with the fall, the values there, I think something like 15, we want it to be pretty quick. So I think jump velocity. And then I'm going to, we'll try it with time. But I have a feeling it's going to need to be switched to something like a height difference. So say 0.1, keep it fairly short. So, all right, we need to handle jumping. So the jumping can only happen, well, if we're doing double jumping, it can happen when we're not grounded. So what we actually need to do to start off with here is we need to check if jumping has been requested. So jump requested. If it's been requested, then we need to check. So we'll have somewhere, I'll move this at a later point. So the bool is jumping. So that'll be false. We'll also have a jump count because we're supporting double jumping. So, okay, jump has been requested. Firstly, we need to check, can we actually do a jump? So F is jumping. So if we're already jumping and config dot can double jump is false, then we can't jump. So we've got a few different ways of how we can, so we'll say trigger jump is true, but if we're already jumping and we're not able to double jump, which can shorten that, then trigger jump is false. Well, there's another scenario. If we are jumping and we can double jump, and we need to then check the jump count, and jump count is greater than or or equal to our max count there of 2. So if we're jumping, we're able to double jump, but the jump count's already 2, then trigger jump is also equal to false. So firstly we check if we can jump. The other thing there is if we can't double, is whether we're actually allowed jumping when we're already in the air. So that's something where, so a double jump, we will be in the air, but it's something where we're mid-jump and then we're applying another jump. So if we're not allowing a jump when we're in air, not due to jumping, we need to check that as well. So we need to look of, okay, well, if we are not grounded, so we are in air and we are not jumping, then we should not be able to trigger a jump. So that should cover pretty much all of the potential cases. There might be other ones we could run into, but the key thing is, so if we are already jumping but we can't double jump, then it's immediately a no. If we are jumping, we're allowed to double jump but we're at the limit, then it's a no. If we're in the air and we aren't already jumping, then we can't jump. So that should mean we're pretty much right. I think of the potential cases. There might be other ones we need to add in, but we can now check, can the jump is permitted? So F, trigger jump. Then what we need to do is we need to update our jump time. So we're going to need a float jump time remaining equal to 0. So first thing we would do is jump time remaining plus equals config jump time. So we immediately do that. So that's good, that'll update that. We can also update our jump count. So this is for the activation of the jump. Then we have the processing of the actual jump itself. So what I would do then is, well, F is jumping. So here we will also set is jumping to true. So we've said we want to jump, that's good. If we are jumping, then we need to check that jump time remaining. So that jump time remaining is going to go down. We probably want to check if we started this frame. Updated jump this frame, or triggered the jump this frame. That way we won't update the time immediately through. So if we didn't trigger the jump this frame, then jump time remaining minus equals time.delta time. So update remaining jump time, F not jumping this frame. So that's good. Then what we need to check is, okay, well, if jump time remaining is less than equal to 0, then is jumping goes to false. We do not reset the jump count though. Jump count, we keep that actually at a low value. So at sort of its existing value, because what we will do is when we become grounded again, we'll reset the jump count to 0. So that looks good. We might actually improve the check here, and num jumps permitted, config can double jump, then it's 2, otherwise it's 1, because we can then check here if it's essentially we can do a check of making sure that the jump count is valid. So what we would do is change this to if jump count is less than num jumps permitted. That way it's going to prevent us, once we've hit double jump, we won't be able to jump again. We also, with this, it'll make sure that we can't try and jump mid-air if we've already started to jump. So, okay, that's looking pretty good. Just going to reorganize this a little bit so it's a little bit neater. So, okay, that's good. We can activate the jump, we can activate the time remaining. Jumping finished. Otherwise, then we need to be updating the movement vector's velocity. So movement vector dot y is going to be equal to config jump velocity. So that should mean that when we go to jump, it'll chuck us up into the air, and then we should then fall back down afterwards. Now, one thing we do want to probably check is this is something where we want to change this so we do get notifications on press and on release, because we want that Boolean to be getting reset. So let's test this out. Let's see how the jump feels. As I said, with character controller, it's all down to feel. So at the moment, I'm able to press space, not really seeing anything happening. So that's okay. We want to come through and we'll check that the activation is happening. So that side is working. Num jumps permitted is 2. Jump count is valid. I did this test around the wrong way. Easy to do. Let's test that again. Running. So it definitely is making me jump. That jump time is probably a little bit high. We can turn off double jumping just in case we've got something a little bit amiss with that. Very easily could be. So let's make sure it's only doing single jumps. It does seem to be less high, but that is a little bit too much. Can try dropping down the velocity, but I think it's going to be a case where we also need to set it up so it's height-based. And that's saying that is okay. I want to make sure the height is... You can see the height is generally consistent, but it does vary a little bit. And it does feel a little bit sort of off. Probably that jump time could really lower that. So if we lower that, then we can see, and that feels better. The in-air control, I think, needs to be a little bit higher, and I think the acceleration needs to be higher, because I think when we're sort of blending stuff out a little bit too rapidly. And that feels still off. If I did drop the acceleration back, because I did change a few things, generally don't want to change too many things in one go, but let's test with that. And that feels okay, but I don't feel like I travel that far during it. So I think that's something where for the air control, if I increase it, that's going to mean it's doing a little bit more. And that's starting to feel better. So balancing with the air control, that feels pretty good, actually. Like that feel is feeling quite good. So, okay, double jumping then. We want to see what's happening with that, because that seems to be something where it's not behaving quite how we would expect. So what I'm going to do is I'm going to get rid of the logging out of the grounded check, because that is working quite nicely. I'm quite happy with how that's behaving. But I do want to log out jump triggered and bring this down to here. Because what I suspect is we're potentially getting multiple sets of that input coming through, which is quite possible. We can see we got 5 of that. So one way that I can resolve this is if I actually remove this. So I go back to, now I only get a notification on press. And with that, what we should see is I only get one. I'll get the jump triggered, and it will come through multiple times. It'll keep coming through. Handy way to test the movement though. But what I can do is here, input jump is false. So I force it back to being false immediately at that point. So there's a way you can work with the input system. It doesn't need to all happen inside the processes there. So now, do that, I get one jump. It definitely can notice, so the reason it was working the way that it was before is it was triggering multiple jumps. So that means I can bring the jump time up a bit. So I might need to again adjust stuff like the velocity. So that's back to feeling pretty good. So whenever I do a single jump, it's just going up by 1. And so I want to then test how well the double jump works. So what I'm going to do is F jump count is equal to 1, just log out that a double jump was triggered. Just want to know that a double jump was activated. Make sure that I'm managing to kick off a double jump, because I do have a fairly narrow time window in which to do this. And it doesn't look like I'm managing to actually kick off a double jump. So I could, to make it really, really, really easy for myself, let's test and see. This I should definitely be able to hit a double jump. So I still don't actually see that output. So what I want to do is any of these areas where I am messing with jump count, I want to make sure that I check these in terms of, am I potentially resetting stuff? Because what could be happening is I start jumping and there is a little bit of a window, and this is what I suspect is happening. There is a tiny bit of a window here where I actually, this goes up to 1 and then that comes back to 0. So what I want to do is change this. So we shouldn't actually do the grounded check if we have a jump time remaining. So if jump time remaining is greater than 0, then we are just going to return hit result. So I'm just going to move hit result up to here. And we are currently performing a jump. So hit result will not be populated in this case. So that's something where we could still potentially do the raycast and give the information back. Got a few options there of what we could do, because we do need that. We could just return, don't think there's a one for like just an empty raycast hit. We could do a new raycast hit and return that, because we can't return a null, unfortunately. We should set is grounded to false in this case, because while that jump is happening, we don't want to be, we want to wait a little bit so we're not incorrectly kicking things off. Actually, I won't keep it attached to Unity. So this should now mean I can kick off the double jump correctly. So, and we did kick it off, so that's good. So if I drop the jump time back to a more reasonable value, then I should now be able to go. And it is a very short time window, because it has to kind of happen in that sort of very short time period. So I could allow potentially a little bit more leeway. What I use as the actual jump time would work sort of for that. But it's because it needs there to actually be a jump happening, and it gets pretty close already to the ground. So I could up the jump time a little bit. This is going to affect effectively, and this is a little bit usability as well, because it's going to affect how high we go, but it is also going to affect how quickly people need to be able to do this. So that's a single jump, and a double jump. So 0.3 is enough. 0.25 might be just enough. So we're able to hit it, so that works. But what I do find with the setup there is the height that we go is a little bit variable. So it does tend to vary a little bit. We've got it pretty solid. The double jump in particular, it's going to be a little bit sort of finicky with. What we could do is we only say that it's been triggered this frame if this is the first jump. The reason being that anything other than the first jump should do that logic. Now, the jump time remaining, we also, with that could go a little bit below 0, which could offset things later. So I'm going to make that 0 when we land. This should clean up some of those little bits where it varies, so that we don't need to necessarily directly specify a height for it. That feels pretty good. And I'm able to double jump. So that's good. I've got my double jump going and I've got my falling going now. And those are both feeling pretty good, which is excellent. And we've got controls over those so we can be turning these things off and on as we need also. Okay, so there's a couple more bits I want to add in, mostly in terms of usability and making it work well with other things. So what I'm going to do is bring in Unity Engine.events, and we're going to start to set up a few useful events. I will also relocate this stuff so that we've got our jumping logic is cleaned up a little bit. Also going to move the jumping into its own separate function. So we're going to have a function here that will be update jumping, and this will have ref movement vector because it does need to be able to update that. So we'll have a protected void update jumping ref vector3 movement vector. That's just going to make it a little bit cleaner. We want to try and keep our setup here nice and clean and easy to be working with. Makes our life a lot easier. So that's good. We've got jumping, jump count, stuff like if that can be accessible, which is cool. So we can start to set up a few other options. So it'd be useful to have a few Unity events. So we'll have a Unity event, and this will be one where we want stuff for landed. So we might be able to have some stuff where we can start playing sounds. We might want visual effects, things like of that happening. So on run changed, and this can pass through a Boolean to indicate if it's running. So it's a new Unity event. We'll have another one that will be on hit ground. So if it's gone from being grounded, from not being grounded to being grounded. So we'll just have a few little, helper ones here that'll just make that a little bit neater. So these are reasonably straightforward. And if it was not grounded, then on hit ground, invoke. Just means we've got that set up there with the running setup. Well, what we can do is we already have a dedicated function for updating the state of the running. So if we go to where this is being run from, we can check was running is the previous state. Then we can check f was running. It's not equal to is running. On run changed, invoke, and we give it the new value. Just means that we've got a little bit of stuff there so that we can react to changes, because you could do field of view changes, stuff like of that. So a FOV kick, a field of view kick, is not an uncommon thing to do when running, it can amplify the feeling of speed there for it. The other thing that would be really handy to have is being able to work with World Space UI. So if I just chuck in a UI, and we're just going to throw in a button, bring in the essential stuff for TextMesh Pro. So this is just going to be a button that is going to sit there in World Space. We'll set up a panel that it can sit on top of. we'll switch this to world space, as I normally would do. Set the hide and everything to roughly reasonable values, so that then we can take that UI and position it somewhere. That's pretty good. So what I want to be able to do is I want to just be able to click on that button. So I'm going to just set up a little script, UI test. Just all it's going to do is just display a message for us. So public void onPressed debug log pressed. So I'll just connect this up, because what we'll see is our UI is actually not going to work typically. We'll need to do a little bit of logic to make it work, but that's fine because that's something we can actually set up. So onPressed, I've got that. It's good. The button, I'm just going to expand it to fill the entire area and shrink that canvas a little bit. Doesn't need to be that large. It's better. So that's linked up, so we can press that button. I'm also going to set up for the here a image, and what this image is going to be, I have to set up a completely new canvas for this, which is fine. This is going to be our HUD, and I'm going to just set up a little image in the center that will be the reticle. So I'll do the screen scaling the way I normally would. 1920 by 1080, like that. The image, conveniently, the knob sprite there is usually pretty good for something like this. Can shrink the size of it. Really important thing we need to do though is we turn it off being a raycast target, and I'm actually going to even remove the raycaster from the HUD there. Reason being, if you don't, it can block the, well, it will block the raycasts, and it can take a very, very long time to actually track down. Now we're getting errors there, that's to be expected. The input system, we just needed to switch that over to using the new one. So what I'm expecting to be able to do, what I want to be able to do, is go over to this button and just go click, and it does stuff. But it won't. And that's because there's a little bit of extra logic we need to actually do. So I'm going to, this I will put as a bool here that can be controlled, because we might not necessarily want this always on by default. We might also want to be able to override it. So what I'm going to do is I'll have it that there is a default option. So user interface, public bool, send UI interactions, equals true, but I will give this a setting here that I can override. So I'm going to have public bool, and it will be same as these other ones. Default it to true, but I'm actually then going to, in a wake, populate that from the config. So the idea being is this is something I want to then be able to, and I will actually allow that to be, I still want it as a property, I don't want it in the inspector. So this will allow it to be something that I can turn off and on externally, which will be handy. Because what I then do is here, well, F input primary action. So if we've said to provide an input, so F input primary action and is sending UI events or send UI interactions. Send UI interactions. Then we need to relay data to the UI. We need to inject data into our user interface. So that means we have to bring in Unity engine dot event systems. And the way we do this is a little bit weird, but this allows us to inject the UI. Need to inject pointer event. And we're going to keep it simple, and we're only going to inject a click event. So what we do first is we construct a pointer event data. So that is a new pointer event data that links to our current event system. We need to give it the mouse position. So we need to set that, which for the new input system, we can go mouse dot current dot position and read value. That'll give us the location. Then we need to perform a raycast. So raycast against the UI. So the way we do that, we get a list of raycast results like that. We go event system, current, raycast all, pointer data, outputs to the results. Then we loop through these. So we go, okay, well, for each raycast result in results. Well, first thing, we want to check the distance because we probably want to have a max interaction distance. So max interaction distance is equal to, let's say, 2. So f result dot distance is less than our config max interaction distance. So that will allow us to check that. That actually isn't an out, that's just results. So then what we do is we go execute events, execute, and then we give it the game object. So result game object, we give it the pointer data, and we tell it the event we're wanting you to execute is a click handler. Now, there is more logic we could potentially set up here if we wanted to check sort of facing, stuff like that. But this will just get us, we should be able to interact with the UI. That's what we're expecting, is that I can, from at this distance and click nothing. But if I get closer, then it presses it. You can see there's press events coming through and it doesn't trigger from behind, which is great. So it's only triggering from where it needs to. So that's great. We've got our character controller. We can now fall, we can jump. The feel of those is good in both regards. And we also have some basic events hooked up that it can be sending through. And we also now have interactions with UI happening there. So it's a really, really great set of stuff we've got up and running. So next time, what we're going to be tackling is stairs. So stairs, very intentionally, are being left as their own sort of standalone thing because stairs are tricky. You know, if we tried going up the stairs at the moment, I suspect the result is going to be, it's going to be bad. I definitely think it is not going to be good if we try and go upstairs. And as expected, we kind of can't. We can go down them, but to get up them, we have to jump the whole way, which is less than ideal. So we want to improve that. So we're going to next time be setting up the capability for step-up support there. We'll also get stuff like sound events going in. So for walking, getting our footsteps happening and adjusting those appropriately for it. Thanks folks, I hope you found the video helpful and interesting. If you have, chuck in a like and subscribe, really helps out, really appreciated. If you've got questions, chuck in a comment below. If you're looking for the code for the project, that code is up available on GitHub. There's a link to that in the description below. You can use this code in any of your own projects, whether those are commercial, non-commercial ones, you're free to be using it there in those projects. And if you're looking for other ways to support the channel, I do have a Patreon. There's a link for that in the description below as well. But until next time, bye.